Okay, class, I'm going to work through the Unit 3 review with you. I'm not going to completely solve each problem for you, so you need to make sure that you are pausing in between and going through and completing the problems. I'm just kind of giving you some hints and helping you set some of these up. Okay, so make sure you get your signature and a parent's signature on this. Alright, this very first one, we're just solving an inequality, and I'll go ahead and solve this one with you just to kind of get in practicing. Okay, so we've got the two sides of our inequality. The first thing we need to do is remove our constant, remove the term that's not attached to our x. So we're down to just x's on one side. So I'm going to take away 5. Since I have 5, I'm going to take away 5. Also, it's plus 5, so I do the inverse operation and subtract 5, whichever way you prefer to think of it. Okay, so 5 minus 5 will give me 0. So I've successfully gotten rid of those. I'll have 3x is less than, now 2 minus 5, you have to be careful. You think about a number line. If you're at 2 and you take away 5, you're going to end up at negative 3. Okay? You've got to be careful with those. And for me, I always have to write it out like this. When I'm seeing a smaller number like that, it's hard for me to visualize it. I need to write it that way. Okay? Now from here, we're trying to get x alone. 3 and x are being multiplied. So I do the opposite and I divide by 3 on both sides. 3 divided by 3 leaves me with just 1x, and I can literally write a single x. I do not have to flip the sign. I realize some of you were making this misconception of if there was a negative number involved at all, you flipped it. You only flip that inequality symbol if the number that you're dividing by is a negative. Okay, so this is a positive 3 that we're dividing by. Thinking of your triangle, this is a negative divided by a positive, so we're left with a negative number, and negative 3 divided by 3 is 1, negative 1. Okay, so our answer is x is a negative 1, and it says to create a number line. So I'm just going to draw myself a little number line. I'll put 0, 1, 2, negative 1, negative 2. Okay, since it's not or equal to, that's our open circle. And this is all in your notes. If I'm doing this and you're like, wait, what? This is in your notes. We have a foldable on this that you should go back and kind of review. Okay, and then I'm shading everything. X is less than or smaller than negative 1. So it's all these numbers to the left. Also, when we have it written with our constant, or I'm sorry, our variable, our symbol constant in this order, we can also just know to shade the direction that the arrow is pointing. So I can shade to the left here. So x is going to be anything less than negative 1. Okay? Alright, I told y'all to draw a triangle here on this one. We've got this triangle. It has angles of, so we'll just say this one is 23.6 degrees, this one is 84.9 degrees, and we're looking for this one, which we're calling x. Okay, so it says write an equation that can be used to find x, the measure of the third angle. So what I'm going to do is, I know that all three of these have to add up to 180. There's 180 degrees in a triangle. So I can say 84.9 plus 23.6 plus x equals 180. Okay, I can combine these two numbers. I can add them up to get one big number, plus x equals 180. From here, to get x alone, you're just going to subtract this number from both sides to have x alone. Basically, you're subtracting these two from 180 to figure out what you have left over to for what that last angle will be. Okay, all three of them have to add up to 180. So you'll need to go back and finish solving this one. Alright, and I challenge you, once you can go back, and I don't even care if you use a calculator afterwards, and even back to this one, plug in 3 times a negative 1, that's negative 3. Negative 3 plus 5, is that 2? Yes. Okay. Here, once you get your answer, plug it in. Make sure the 84.9 plus 23.6 plus whatever you get all adds up to 180, okay? Even if you're using a calculator now to check your work, that'll tell you if you did something right or not, okay? Write equations that represent each of the following and then solve them. So for each of these, we're writing and solving the equation, okay? Some of the classes, we did this one together. The main thing, we talked about this in class, there's not really a formula. It's hard for me to do this on here because there's not really necessarily a formula or steps for how to write the equations. You just have to be able to read, identify the different parts of your equation and put it together. So some tips that I've given you, figure out what the whole thing equals. And then if from there, so in this one, the membership fee, we've got the health club charges one time $40. And words like and tell us to add. It charges $25. Words like each, that tells us that the 25 is most likely going to be attached to my variable. Okay, $25 for each month. Okay, it wants to know what the total fee after n months is, or it's saying that the total fee after a certain amount of months is $240. That's looking like what it's going to equal, and we have to figure out how many months that they paid for if they paid $240. Okay, so for this one, I know that it's going to equal 240, so you can say equals 240, or you can even say 240 equals. Doesn't matter, whichever way you like to write it. The one-time amount, that's your constant. That's, he paid $40 done over, that's it. Okay, so we've got this one-time fee of $40 plus $25 times each month. Okay, so if I wanted to know what it would be for 2 months, I would plug in 2 here. 25 times 2 is $50 plus the initial $40. For 3 months, I would plug in 3 plus still I paid that initial $40. Basically, what you're doing by solving this is you're figuring out what you can put in here to make this equal 240. How many months? $25 a month plus that initial $40 will give you 240. Okay? And you think about it, when you solve it, even if we hadn't written an equation, we probably would have said, okay, I know that 40 of those dollars, 40 of these $240 was for the application fee, or that one-time fee. So I take that out and I know, okay, I've spent $200 on the monthly part. Take away that, and I know that I've spent $200 left over, and that's what I've spent on the monthly part. So I can divide up the $25, and that's going to tell me, okay, each month was, I've paid for my gym membership how many months. Okay. A runner warms up for 10 minutes, and so plus, then takes 7 minutes to run each mile. Okay, that just kind of told me that that 7 minutes is being multiplied with the variable, which is miles. Okay, the total time after our miles is 45 minutes. So everything is going to equal 45, so we can write it this way this time. 45 minutes is going to equal, how did we get to the 45 minutes? We did an initial 10 minutes, done over, that was the warm-up, nothing else was dependent on that. We just had the initial 10-minute warm-up. And so plus, now we ran 7-minute miles, and we want to know how many of them we ran. Okay, and if you think about it, this is a minutes, 45 minutes. This is a minutes, 10 minutes, and this is the minutes, and it can be multiplied with however many miles. So if we ran 2 miles, 2 miles at 7 minutes each, that would be 14. 3 miles, that would be 21 minutes. Okay, so this is going to become, when we multiply it, will become minutes as well. Okay, that's another way to check if you've written it correctly. If everything, for sure your constant and your answer are in the same units, and then this, when it's multiplied together, will be in the same units as well. Okay, and I'll let you still need to solve this one. Okay, and make sure your answer makes sense. And like I said, and I've been bad because I'm trying to move through this, go back and make sure that when you plug in whatever you get for this, that it works in the equation that you wrote. Alright, a tutor works with a group of students. The tutor charges $40 plus, well look at that, it even told us the operation, plus $30 for each student in the group. Today the tutor has S students and charges a total of $220. So we know that this is all going to add up to $220. How did we get to $220? Well, they have just an initial $40 fee, just for the sake of the fact that they're tutoring, plus then they charge $30 for each student, which we're representing with the letter S, or the variable S. Okay, so when we solve this, I'm going to take away the $40 first, my constant first, say, okay, let's get the amount that they paid down to just what they paid for the students. So 40 minus 40, 0 gone. Over here I still have my 30S. 220 minus 40 would give me 180. Okay, from here I can divide up the $30 for each student with the amount total that they have left. 30 divided by 30, that leaves me with 1, or I'm basically figuring out S, what the price for one student was. Or wait, this is the price, I'm sorry. S, how many students paid. If each one's $30, it was $180 total. This will tell me how many students paid. Okay, I'll let you finish that. Alright, trying to pick up the pace a little bit here. This is just another, we'll do this one together because this one's kind of, okay, Jessica's selling candy bars for a fundraiser. She sold 17 candy bars the first day. Okay, that's just a statement. That is that 17, that's just done and over. Okay, 17 candy bars. After that, she sold 7 candy bars a day, or each day. Okay, if her case had 80 candy bars total, how many days would it take her to sell the entire case? Okay, so we know that whatever she sells, it has to equal or add up to 80. Okay, I can just drop my pencil. I can see that the initial, or the constant, is that original 17, plus after that she was selling 7 times, we can say D for days, or you could put X, it doesn't matter, but 7 per day. Okay, multiplying, when you're multiplying, the word a lot of times that we see with that is per. When you say per, or when you see that, that means to multiply. So if we're saying originally she sold 18 plus 7 per day, 7 times the number of days. Okay, when we solve this, it'll tell us how many days it took her to sell all of her candy bars. I can tell you if she came to my class, or it would not take very long. Okay, so consider the equation. This is just a regular equation. I do want to do this one with you, or part of it. So the first thing we're going to do, and I know some of you would be tempted to add 2, but that 2 is connected to the X. So I can't just take away the 2. The first thing I need to get rid of is this constant. If I have 5, to get rid of it, I can subtract 5. Okay, 5 minus 5 is 0, so I can say they're gone. 11 minus 5 is 6, equals, now here's the part that catches some of you. That minus sign was also being used to say that this is a negative 2, so we can't just get rid of it. I have to carry down that negative 2x, okay? And from here I have to divide by negative 2 on both sides, okay? And as you finish solving that, remember you've got your triangle to make sure you get the right answer, okay? It says use the model. Well, what this is really saying is, just like we did when we did our algebra tiles, I want to solve for what 1x is. Well, these are negative x's, so I would have to add a positive x there. If I add one over there, I have to add one over here, and a positive x here. Okay, a negative and a positive cancel, and a negative and a positive cancel. So now I have all my x's over here. I got to get rid of all of these. There's 9, 10, 11, so I'm not going to draw all of them, but I would do 11 negatives. So So those all cancel. If I did 11 negatives there, I have to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 negatives over here. Those all cancel because that's a negative and a positive. Then I have 6 negatives left between my two x's. So each x is going to get 3 negatives, okay? And I don't really care about the model. I care that you've solved it. I guess we'll just go ahead and solve this. 6 divided by 2 is 3, and a positive 6 divided by a negative 2 is going to give me a negative 3 is what x equals. And each x got 3 negatives. Okay, I don't really care about the model. If the model confuses you, I'm not worried about it because I know if you can do this, then I'm good. Some of you prefer to see it like this and it helps you. That's great. Whatever way works. Right here, this is just the same thing. You're just using decimals, so be careful. Same thing as above. The first thing I'm going to do is take away that 1.2 from this side. So I'm going to subtract 1.2. 1.2 minus 1.2 is 0, so I can cross that off, but that minus sign is still there. It's still being used to say negative 7x is less than 5.6. Okay? Gives me that. Now, be careful because we're about to divide by a negative 7 on both sides, so my sign is going to flip. Okay? And I'll let you finish that one. Alright, this one, find the measure of each angle. So we're given this one, DAE is 50 degrees. Before I even did this, I'd probably just go in and go ahead and fill all this out. I know that this is 90 degrees. If this is 90 degrees, if you're stuck on this stuff still, we have notes on this. But vertical angles, remember, across from each other are equal. So if this is 90 degrees, this is also 90 degrees. And then right here, I know that CAE is a complementary. This is going to be 90 degrees. This is a complementary angle. So if this is 50 degrees, let me, just to make sure you're seeing this right. That's a complementary angle. So if this is 50 degrees, whatever this is has to make 90 degrees. Well, if I say 90, 50 plus some degrees equals 90, subtract the 50, x is going to be 40 degrees, or this is going to be 40 degrees. Okay? And then we can just use our vertical angles to finish the rest of this. Opposite angles, these vertical angles are equal. So if that's 40 degrees, this is 40 degrees. That's 50 degrees, that's 50 degrees. Okay? And I'll let you... And just to check, you can say, okay, from here to here, these are supplementary angles. All of these have to add up to 180. Well, 50 plus 90 plus 40 gives me 14 plus 4 more, 180 degrees. So if we're using our rule of supplementary angles, it's still working. Okay? Okay, so I made a silly mistake when I was doing this one. I added up the whole thing because I didn't read this. It tells us the monthly total for this guy down at the bottom. So I don't even have to add them up. $3,200. So this is the data for a family living in Abilene. The amount of money that they need each month to live on is $3,200 or $3,200. Okay, it says if a one-parent family with 2 children living in Abilene, the father works 32 hours per week, okay, each week, assuming a month has 4 weeks, write an equation that can be used to determine W, the father's minimum hourly wage, in order to meet the family's estimated minimum monthly budget. Okay, and it says solve the equation. So what I'm going to do is it's asking about the month. Okay, so I need to figure out how many hours he works a month. So if he works 32 hours a week times, it's saying assuming that a month has 4 weeks, times 4, that gives me, that's 8, 3 times 4 is 12. Okay, in a month he works 128 hours each month. okay? If I need him to, so 128 hours times W, what he needs to make for each of those hours, so I'm multiplying 128 hours times W, whatever he makes for each one, has to be bigger than or at least equal to $3,200. Okay? The amount of money that he makes in a month has to at least be equal to, if not more than, we would love to make more than the minimum amount. That's the amount that he needs, which we got from our table. Okay? This is just a one-step equation. From here, 128 and W are being multiplied, and you just need to get W by itself. Okay, more inequalities. She can spend up to $30 each month for her cell phone. The cell phone company charges $20 for her plan. So that's an initial constant, that's a one-time $20. Okay, so that would be our constant. Her plan for 25 cents for each text message. For each, that's telling us that the 25 cents is going to be multiplied with our variable. How many text messages can Andrea send without going over $30? Okay, so this is going to be an inequality, and I'll set one more up with y'all, but so $30, actually I want to start the other way. So we're going to say she has that initial $20 that she has to pay for her plan, plus, now you can't just say 25, you have to say 0.25, 25 cents for each. I'm going to just use X for each text message. Okay? Now it's got to equal 30, but I'm using an inequality symbol, so I have to figure out which direction my inequality symbol is going. If I do it this way, it's saying that this amount that she spends is more than $30. Well, she doesn't have more, all she has is $30. So I have to write it this way, which is saying the amount that she spends is either less than, or I could set it equal to $30. She could spend exactly $30, she just can't go over $30. Okay? I'll let you solve this one. Be careful when you divide, that's a 0.25, that's a decimal. Okay? So an airline charges for checked luggage that weighs more than 50 pounds. Marla's suitcase currently weighs 36 pounds. That's all by itself. Okay? And she still needs to pack 2 pairs of shoes. What is the maximum amount each pair of shoes can weigh? So it looks like my 2 for my 2 pair of shoes is going to be put with the variable. Okay? I'll keep solving them. I'm wanting you to do some of these on your own, but I want you to maybe challenge you, pause it, see if you can write it, and then press play and see if you've written the same equation or inequality that I have. Okay, so she's got this 36 pounds. That's what we know for sure. That's our constant, all by itself, 36. And, so that tells us plus she's got these 2 pairs of shoes that are, I'm just going to say X pounds each. This amount has to be less than, or it could be equal to 50 pounds. Okay? I know that it's totaling 50 pounds. I know that this is my constant. It's just the 36 pounds, but I'm trying to figure out how many each of these shoes can be. Okay? And I'll let you solve that. This is just a regular inequality. I'll let you solve that, and you can use the model, but mainly as long as you know how to solve, I'm not super worried about you doing the model, which is down here. Okay, each one of these we're just solving for n in each one, and you're matching it up with the graph. Now, we did talk about this in class a little bit. These are all just equals. They're not inequalities, so we're not worried about shading. It's just going to be n equals, one of them will be n equals -9. So that's why we just have one closed-in dot on -9. Okay? 12, Mrs. Parr, she's got this budget. I'll let you read that, but here's the equation. She already has a list of 30 teachers she wants to order baskets for and plans to add more to her final order. Okay, so will Mrs. Parr have enough money to add 18 more baskets to her final order? There's two ways you could do this one. The first thing that you need to identify either way is that if she has 30 and she wants to add 18 more, so we're trying to figure out if Mrs. Parr can afford to buy 48 gift baskets for her teachers. The way I solved it was I put in 48. I plugged in 48. So I said, okay, 12 times 48 plus 60 needed to be less than or equal to $600. Okay? You could have also just solved this equation, and if G was not at least 48, or if G was over 40, wait, I'm trying to think here. G would have to be, I'm blanking. That's the gift baskets. So it couldn't be over, I'm sorry, G is going to tell you how many she could have. So if 48 is more than what she can have, if 48 is more than G, that's what I was trying to think of. Okay, if 48 was more than G, whatever you get for G, then she can't afford it. Give me 1 second.
We are ready to switch stations. 6th grade, you're going to your choice. 7th grade, you're going to the football field. And 8th grade, you're going to the carnival.
Okay.
6th grade's going to the activity of your choice and study hall.
Okay. So you can solve it this way. You can plug in 48. If this is bigger, if this is not less than or equal to 600, this amount that you get is, if it is not less than or equal to 600, she can't afford the 48 gift baskets. If you solve for G, if the number that you get, if G is something less than 48, we can't afford the 48. Okay? That's about it for that one. I'll let you finish solving that. This is just a regular inequality. I'll let you solve that. Just be careful with your decimals. Okay, this is an interesting one. Joseph works at a warehouse packing crates. His job is to place B bundles that each weigh 3 pounds into a crate that weighs 5 pounds. If Jack can lift up to 65 pounds, write and solve an inequality. Oh, and I realized they made this mistake too. That should say weigh. Inequality to represent the situation. So we know that the total, or what this is going to be, is 65. We've got to create something that has to be less than.
Anthony Culp, come to the office, please. Anthony Culp, come to the office.
Okay, this is what he's going to lift. It has to be less than, or it could be exactly equal to the 65 pounds that Jack can lift. Okay, well, I know that what he's lifting, we've got this crate that's 5 pounds. So that's 5 pounds of what he can weigh, or lift. Plus, then he's got these bundles. They're 3 pounds each, and we want to know B, how many of them we can lift. Okay, so when you go to solve this, it makes sense that the first thing you're going to do is subtract 5 from both sides. 5 minus 5 is 0. But what you're doing is you're taking out, you're saying, okay, if he can only lift 65 pounds, I know that 5 of those pounds are going to come from the crate. So he's left to 60 pounds that he can lift of the bundles. Well, if each bundle weighs 3 pounds, I'm going to divide by 3 on both sides. Or divide by 3, divide the 60 pounds into 3 pounds to figure out how many bundles he can lift. Okay? So when you think through it, when you understand, having a word problem that goes with an equation kind of helps, because it helps you understand the steps that you're doing. Okay, Mrs. Zielinski is planning a field trip to the bowling alley. $4 per guest, plus $120 party fee. Okay, she has this much money, so that's my total.
E. Pellet, come to the office, please. E. Pellet, come to the office.
Okay, and it even gave us the equation. So 4 times S, however many students, plus the initial just $120 fee, that's our constant, has to equal $1,080. Okay, So what you're doing is you're solving this. Again, there's two ways you can do this. You can plug in 250 and see if it will be less than or equal to $1,080, or you can actually just solve for S and figure out if this number is more than. I keep getting myself confused because I didn't solve it that way. So if this number is smaller than what you get for S, if 250 is bigger than that, we don't have enough money for all 250 of them. Okay, so I'll let you solve that equation. 4S plus 120 equals $1,080 to figure out how many students can go on the field trip, and then be able to say if 250 students can go on the field trip or not. Okay, have this done for Monday, and I'll see you then.